I posted on this website, so hopefully everybody's been to this website. If you look under Chapter 2, let's see, right down here, homework. I'm going to hit download. We're going to open that. So you can get there from the Itinerants webpage, or you can just Google my name, make sure you spell it right, and that website will come up. Just follow the stuff for Chapter 2. I've got loaded up here. This looks a little bit different than what you've got on your paper. I've got the review assignment in here now. This is the review assignment for 2.1 through 2.5. There are 33 questions, I think. I want you to do 28 of them. We're going to keep the test date the same, so that'll be on Monday, so make sure you're ready to go for that. Tomorrow's just review, so it would be great if you go home, get done with 2.5, come tomorrow with questions on 2.5 and the review. We'll turn in 2.5 and the review on Monday, although it would be really nice if you were done with 2.5, tomorrow partway through class, and then could spend the weekend working on the review. So the questions for the review are right here, right there. Okay, oops, highlight those. Okay, so you can pull it up, look at those. That way I don't have to print another one. Because the only thing that changed on this one from the other one that I handed out is I just put the 2 review assignments. Okay, any questions? Okay, so make sure you access that you've either downloaded it or at least written down which ones you need. And then we're going to pick up where we left off. Yesterday we started 2.5 and we went over a whole bunch of ideas about polynomials, about how we can factor them, about how the factors are related to the zeros, how many zeros we're looking for, if there are any nice zeros, what they might look like, the fact that if they have any imaginary zeros, they always come in conjugate pairs and stuff like that. So let's focus on these 2 ideas right here. This is the rational zeros theorem, or we're going to refer to it as the P and Q stuff. Okay? So if we're going to find any of the nice zeros, or any of the zeros, we want to find the nice ones first, and that's what that theorem is going to help us do. We can come up with a list of possible rational zeros, and you have some problems on your assignment, and maybe some problems on the test, where all you need to do is just be able to list those. Okay? And then, of course, we use synthetic division to figure out which ones are actually zeros. And then we've got this idea right here that's relatively simple, but extremely useful. It's the idea that if you have imaginary zeros, they always come in conjugate pairs. So if you're given one of them, you actually get 2 for 1. So like on this example right here, if 2 minus 3i was 1 0, then 2 plus 3i is another 0. If 4i is a 0, then minus 4i is also a 0. So we talked about those ideas. And then we started off doing a couple of problems. And let's see, let's take a look at example 10. That was the last one that we did, and then we'll just do all the rest of the problems today and make sure you're in good shape for doing the homework. So they gave us a graph right here, and they gave us a polynomial, and the instructions were list the possible rational zeros, okay, so use the P and Q stuff in order to come up with a list, and then look at the graph and make sure that all of the zeros on this polynomial are actually on this list, okay? So they did you the favor of actually graphing it for you. You don't have to pull it up on a calculator or anything like that, but we may do that at some point here, okay? All right, so let's take a look at number 11. Number 11 says, use the rational zeros theorem to find all the real zeros. All the real zeros. So the key word there is real zeros. We're only looking for real zeros. If we happen to find something that has an imaginary zero in it, we're not going to worry about that. And then it says, use the zeros to factor it over the real numbers. Okay? So let's take a look at this. It says, use the rational zeros theorem. So that's the P and Q stuff. Tony, what's P on this problem? Okay? We could say 20 or negative 20. Doesn't really make any difference. Okay? Hope, what's Q? Q is 1. Now, is that nice when we have a Q of 1? That's darn nice, because if you go through and list down the factors of 20, 1 and 2 and 4 and 5 and 10 and 20, that's all of them, isn't it? Because if I were to list all those factors and then the factors of Q, The only factor of q is just 1. So it would be each one of these over a 1. So there's my list right there, except for one thing. What else do I need to do? Put the plus or minus. Okay. Now, how many real zeros can this polynomial have? How many real zeros can this have? Up to how many? Up to 3. Okay, because it's degree 3, it would be up to 3. Okay. So let's check and see if, what would be the easiest number to check here? Probably 1. Okay. So let's put 1 in the box. Okay, and we're going to check these using synthetic division rather than plugging them in. I'll show you another way to kind of check this in just a minute. Okay, I need to make sure that all the powers are represented. So it's in descending order and all the powers are represented. It is. There's a cube, there's a square, there's an x to the first, and there's x to the 0. So I'm going to write down a 1, an 8, an 11, and a negative 20. And again, the key to getting these right is to make sure you evenly space everything. Synthetic division, we're going to move the 1 down, multiply, add, that's a 9, multiply, add, that's a 20, multiply, that's a 20. Now remember, what goes in between these last two? A little dotted line, and what we're hoping for here is a 0. Because if this is a 0, what does it mean about this right here? Okay. It means this is a 0 of the polynomial, and it means it corresponds to a factor. What would the factor be that corresponds to a 0 of 1? It would be x minus 1, right? Okay, this stuff right here is called the depressed polynomial. This used to be degree 3, but we divided by an x, so this is now degree 2. So this is x squared plus 9x plus 20. Okay, and what's nice about the depressed polynomial here? You could name a couple of things. So what's nice about the depressed polynomial, Lynn? You can factor it. Okay, the nice thing about this depressed polynomial is it's pretty easily factored. It's a degree 2. Okay, what's nice about every depressed polynomial is it's at least a lower degree, so it's going to be easier to work with. Okay. Now, if I can factor this, I want to factor it. If I couldn't factor it, what would I use to find the zeros? Quadratic formula. Now, this one does factor. We're looking for two numbers that multiply to be 20, that combine to be positive 9. What two numbers would those be? Positive 5 and positive 4. So, remember it said factored over the real numbers? Did we just factor it using real numbers? We did. So these are the factors. What are the zeros? What's the 0 that comes from this factor? 1. From here, negative 5. And from here, negative 4. Okay? So here are the zeros. There are the factors. Are all of these zeros in our list of possible nice zeros? Possible rational zeros they are. Okay? That would be a really good test question, because it checks to see if you know how to do all this stuff. Can you use the P and Q stuff? Can you use synthetic division to identify a 0? Can you make the factor that comes from that 0? And can you factor or find the rest of the zeros from the depressed polynomial? Okay, a little bit on the easy side by the time we're done practicing this. Okay, any questions? Okay, go ahead and flip the page over. Take a look at the instructions for this one. This is now an equation, and it says solve the equation over the real number system. So we want to find all the real solutions to this. Okay? Not any imaginary ones, just all the real ones. How many are we looking for? Up to 4 real ones. Up to 4 real ones, because it's degree 4. Okay? Now, if we're going to find any of the real zeros, it would be nice to find the nice ones first, the rational ones first. So what are we going to use? P and Q. We're going to use P and Q. So let's write down what P is and what Q is. Okay? Again, I've picked some fairly nice ones here to start off with. P is 8, Q is 1. We really like it when Q is 1 because that makes it a heck of a lot easier. That makes our list of possible rational zeros just the factors of P, and they're all whole numbers. So we'd have 1 and 2 and 4 and 8, all with pluses or minuses in front of them. Any questions? Okay. Watch, please. You can check 1 pretty easily without doing synthetic division. Because if I plug in a 1, remember, the function value is going to be the same as the remainder. So if I plug in a 1 and I get a 0 out of the function, that means the remainder would be 0 also. So if I were to plug in a 1, all that happens is this would be a 1. It's the same as the coefficient out front. What would this be if I plug in a 1? It's going to be an 8. That's going to be an 11, and that's a minus 20. That's 9 plus 11. That's 20. 20 minus 20 is 0. So you could visually check to see whether or not 1 would work just by looking at the coefficients. So let's take a look at this one and see if that works here. If I were to plug in a 1, this would be a 1, a minus 1, a positive 2, a minus 4, and a minus 8. Is that going to make a 0? It's not. So is 1 going to work? It's not going to work. Now, just for the heck of it, I'm going to show you that it doesn't work using synthetic division. Make sure they're in descending order. All the powers are represented. So this is going to be a 1, a negative 1, a 2, a negative 4, and a negative 8. Lots of little numbers to keep track of here. Bring down, multiply, add those together. And when I multiply here, that's a negative 2. So do I get a 0? Nope. So that means this is not a 0. So if 1 doesn't work, I mean, the next most logical choice would be to choose negative 1. Let's try that. Actually, since I've got the advantage here, and you can probably write smaller than I can, I'm just going to change this to a negative 1 and erase all those. So this is going to be a 1. That's going to be a negative 1. That's a negative 2. That's a positive 2. That's a 4, right? Any mistakes here? Lots of multiplication and addition and stuff like that. Pretty easy to make a mistake. This is going to be negative 4. So this is going to be negative 8. And multiply here. I get a positive 8, so I end up with a 0. So what does that mean about this right here? Okay, that means that is a 0. That means it corresponds to a factor. What's the factor that it corresponds to? X plus 1. Okay, what is this right here? It's the depressed polynomial, and it starts off with x to the what? X to the third. So this is x to the third minus 2x squared plus 4x minus 8. Now, take a look at the depressed polynomial. It's a lower degree, so that's good. What else is nice about it? It's got 4 terms. Do we know how to factor 4 terms, or at least how to try and factor 4 terms? Okay, take a look at this. This one is a 1, and that's negative 2. This is the opposite sign, and it's twice as bigger. Twice as big. Twice as bigger, that's a great word. Okay, this is 4. This is 8. It's the opposite sign, and it's also twice as big. So this looks pretty good. What can I take out of the first 2? X squared. What's left? X minus 2. What can I take out of these guys? I have to take something out. I'm going to take out a positive 4, and I'm left with x minus 2. So they both have an x minus 2. And I'm left with an x squared plus 4. I'm going to keep that factor right here. Okay, does this one factor? Does it have any real answers? Easiest way to check would be, let's set that equal to 0. Let's move that over to the other side and take the square root of negative 4. I get x equals plus or minus 2i. Definitely not real answers. Okay? They're complex answers, but remember, it said solve the equation over the real number system. So from these factors, I get answers of negative 1, I get answers of 2, and from here, I'd get answers of plus or minus 2i. Do I use those with the real numbers? Nope. So the answers on this one are just negative 2, negative 1, and positive 2. Those are the two answers. Now, there are two more. How would we have to change the instructions so I could include these other two answers of plus and minus 2i? Yeah, they'd have to say solve it over the complex number system. Okay? Any questions? Okay. Now, yesterday there was a whole bunch of stuff we went over, a whole bunch of theorems, a bunch of ideas. In practice, is this that hard to do? Hopefully not. It does take some practice. Hopefully we're in pretty good shape. Okay, this one says find all the zeros. Does it specify real? Nope. So that means we're going to find all of them. How many are there going to be? There are going to be 3. We're going to find all 3 of them. Okay? What are we going to start with? P and Q. P is 3. Q is 2. So I list the factors. So this would be 1 and 3. This is going to be 1 and 2. Let's list the possibilities. So I'm going to take each one of the factors of P and put it over 1. So I'm going to have a 1 and a 3. Then I'm going to take each of the factors of P and I'm going to put it over 2. So I'm going to have 1/2 and 3/2. That's all of the possibilities as long as I put a plus or a minus in front of each one of those. So I've got 8 possibilities. Is there any way that all 8 of them could work? No way, because remember, we can only find 3 of them. Okay? All right. Any questions? Okay, what one do you want to try first? Try 1. Always a good idea to try 1. Should we try 1 using synthetic division, or should we kind of eyeball it and see if it's going to work? With 1, it's pretty easy to check right here. This would be a 2 minus a 1 plus a 2 minus a 3. Is it going to work? It is. No question about it. So I'm going to put a 1 in the box. We know this is going to work. Again, make sure that we've got all the powers represented and that it's in descending order. Bring down, multiply, add those together, multiply, add those together, multiply, add those together. Just like we expect, we end up with a 0 right there. So that means this is a 0. That's a solution or an x-intercept of that polynomial. It corresponds to a factor of x minus 1. Now, I like to do this every time. I like to write that that's a 0. I like to write down the corresponding factor so I don't lose track of it, so I don't forget it. Here's the depressed polynomial, 2x squared plus x plus 3. Now, it is a lower degree. The depressed polynomial is always going to be a lower degree. Is it factorable? Multiply the 2 and the 3 together, that's a 6, positive 6. Are you going to find numbers that multiply to be positive 6 and combine to be positive 1? Even if you're thinking for that long, I'd bag the factoring, and what would we try? Quadratic formula. Okay? So let's take this right here and let's find the answers using the quadratic formula. So it says, let's see, this would be negative 1 plus or minus the b squared, so that would be 1, minus 4 times a times c. And remember, be careful right here, because this is going to be a 2 and a 3. And then that's all over 2a, so that's all over 4. Any questions there? Okay. Careful right here. This is going to be 1 minus. So we're definitely going to have a negative underneath the radical. This is minus 24, right? So this is negative 1 plus or minus radical negative 23 all over 4. Now, if this said factor, we'd have quite a bit more work to do. This said find all the zeros. I already found one of them right here. How many are contained right here? 2 of them. One of them is negative 1/4 plus I radical 23 over 4. The other one is negative 1/4 minus I radical 23 over 4. Notice how they're conjugates. And the other one was the one we found to begin with. It was 1. There are all the zeros. 2 of them happen to be complex. They happen to be imaginary. They came in conjugate pairs. And then the other one is just the positive 1. Any questions? Okay, and again, do you notice a difference between the instructions here? Find all the real ones, just the real ones. Find all of them, including the complex ones, and take a look at the instructions here. Find all the real zeros and factor it. So we had to factor it and list the zeros. So make sure you're following the instructions. Any questions? Okay. All right, now let's take a look at these last two problems. You'll notice I didn't leave much space for work. That's because on these problems, these are mostly just thought questions, and you have some that are literally this easy. All you have to do is know what we've been talking about, think a little bit, and you can just write down the answers. So it says for number 14, use the information to find the remaining zeros of the polynomial. So the information on part A says we've got a degree 4 polynomial. How many zeros would it have? 4 complex zeros. And it says it has a 0 of I and a 0 of 1 plus I. Well, if it's got a 0 of I, it's also got to have a 0 of negative I. There's another one. If it's got a 0 of 1 plus I, it's also got to have a 0 of 1 minus I. Okay? Any questions? Okay, let's take a look at this one. Degree 6. How many complex zeros is it going to have? It's going to have 6. There's one. It's a real one. Do they come in conjugate pairs? They don't. So that's all we've got from that one right here. 2 plus I. 2 minus I would go along with it. Negative 3 minus I. Oops. Negative 3 plus I would be its conjugate. And 0. That's a real one. That's it. How many do we have here? All 6 of them. Done. End of story. That's it. Any questions? Okay. On the next problem, here's what we want to do. It says, find a degree 3 polynomial with real coefficients that has zeros minus 4i and 3. Degree 3. How many complex zeros will it have? 2. How many how many will it have? 3. How many did they give us? 2, but really when they gave us this one, what other one did they give us? They gave us 4i. Okay? So, do I have all 3 of them now? Okay, now, if I have all 3 zeros, could I make 3 factors so that I can make a polynomial from it? Yep. Let's take this one. This would be x plus 4i, because remember, it's always x minus whatever the 0 is. Then it's going to be x minus 4i. Notice how those even look like conjugates there. And then we'd have x plus 3. Any questions? Okay. Yeah. Oh, yes, it would be minus 3. Thank you. Yep, because that was a positive 3. It's going to be minus 3. Thank you for catching that. Okay, good there? Okay, they asked us to make a polynomial. This is not a big deal. It's a little bit tedious, but the problems on your assignment aren't any more difficult than this. If we actually want to make the polynomial, what we'd need to do is we'd actually have to multiply the factors together. So it's always best to multiply the imaginary conjugates together. So let's go ahead and do that. This is going to be x squared. This is going to be minus 4xi. This is going to be plus 4xi. And this is going to be minus 16i squared. What happens to these two middle guys? Cancel each other out. Remember that whole difference of squares thing? Okay. That one's an x squared. What does minus 16i squared count as? Positive 16. So I'm going to take x squared plus 16 and I'm going to multiply it by that last factor of x minus 3. So again, we'll just distribute through. So that's going to be x cubed minus 3x squared minus 16, or excuse me, plus 16x, and then minus 48. This right here is the polynomial that has those 3 complex zeros. Okay, so do you see how this is going completely backwards? Normally we start with the polynomial and we have to come up with the factors and the zeros. Here they gave us the zeros. We came up with the factors, multiplied them together, and now we've got the polynomial. Okay, any questions? Okay. Go ahead and flip the page over. This is problem number 16, and we've got 16, 17, 18, and 19. So we've got 4 more problems and about 25 minutes to do these. Okay? Now, some of these are going to be a little bit challenging. Okay? This one here in particular. So let's take a look at this one right here. It's degree 4. It says find the complex zeros. Okay, and write it in factored form. So we've got to do everything on this one. We've got to find all 4 of the complex zeros, and we've got to write down the factors that they correspond to. Okay, so let's take a good look at this one. If we're going to find any zeros, we want to start with the nice ones, which means we're going to start with what? P and Q. So P in this case is 18, Q in this case is 3. There are a lot of factors of 18, so I've got 1 and 2 and 3 and 6 and 9 and 18. Does that cover them all? Okay. Factors of 3, 1 and 3. Okay, I'm going to write my list right here. So I'm going to write down all of these, all 6 of those over the 1. So that's going to be a 1, a 2, a 3, a 6, a 9, and 18. Then I'm going to write all 6 of these over the 3. So the next one would be 1/3, 2/3, 3 over 3. That's a 1, already in my list, right? 6 over 3, 2, already in my list. 9 over 3, 3, already in my list. The rest of them are already in the list, so here's our complete list once we put pluses and minuses in front of each one of these. So this is a pretty extensive list. Let's see, 1, 2, 3, 4, 5, 6, 7, 8 times 2, 16 possibilities. That does not sound like fun to check all of those. Okay, take a good look at this. And let's think about this. Let's think about some of the ideas that we've talked about here. What would we normally start as far as checking zeros? What would we start with? Start with 1. Okay, now, if we just did synthetic division, that's going to take a little bit of time because this is a really long polynomial. There are 5 terms here. Okay, what would happen if I plugged in a 1 here, and here, and here, and here? I'd get a 3, and a 5, and a 25, and a 45, and then I'd subtract 18. Is there any way I'm going to get a 0 out of that? Nope. 1's not going to work. In fact, stop and think for just a second. Everybody pay attention to this because this is important. What would happen if I plugged in a 2, a positive 2? Wouldn't this number get even bigger than 3 and still be positive? Even bigger than 5 and still positive, even bigger than 25 and still positive, and then all I'm going to get to do is subtract 18. Are any of these big positive numbers going to work? Not a chance. No way. So I could take this list and I could say, you know what? I'm not going to worry about any of those positive numbers right there. Maybe the negatives, but none of the positives. Now, the fractions, that's a little trickier. Maybe if I plug in a 1/3, maybe it makes this number smaller and smaller and smaller so that the 18 would cancel it out. Does that make sense? Okay. So if that's the case, what one do you want to try first? If 1 doesn't work, and we know 1 doesn't work, how about we try -1? Okay. So let's check and see what happens when we plug in a -1. Now, I could plug it in here, and you might want to think about what would happen if I plugged in a -1. It will change all of the odd ones. It will change their signs. You can check and see if that works. Oops. But let's go ahead and do this. So this is going to be a 3, a 5, a 25, a 45, and a -18. Bring down. That's a -3. That's a 2. That's a negative 2. 23. Multiply here, so that's going to be, what do we got there? Negative 23. Doing okay? Let's see, what do I get here? Is that going to be it? Not going to be it. Okay, what do you want to try next? What? 1/3? Okay. So Sven's suggestion is, none of these positive ones worked, but let's try 1/3. Okay, 1/3 would make this number smaller. It would make that number smaller and that number smaller, and then maybe 18, maybe that will cancel it out. So let's put a 1/3 here and let's see what happens there. So if I bring this down, now remember, synthetic division with fractions isn't that fun, but let's see what happens here. This is going to be a 1, so that's a 6. Multiplying here, that's going to be a 2, so that's a 27. That's going to be a 9, so that's going to be a 54. And when I multiply 1/3 times 54, that is, lo and behold, 18, so we end up with a 0 right there. Okay, now, remember, it says find the zeros and write it in factored form. So this is a 0. The factor that it corresponds to is x minus 1/3. And let's take a look at what we've got right here. This is the depressed polynomial. This is going to be 3x cubed, 6x squared, 27x, and then 54. What's nice about that? Smaller degree, depressed polynomial, 4 terms. Might it factor? Maybe. Let's group these two together. What can I take out of here? 3x squared. We're left with an x plus a 2. What can I take out of here? Do 54 and 27 have anything in common? 27. Grab your calculator if you need to. 27 goes into both of those, so pull out the 27. We're left with an x plus 2. And lo and behold, x plus 2, 3x squared plus 27, and I've got an x minus 1/3 sitting out here. Okay, any questions? Okay, let's take a look at this one right here. Is that factored completely? Nope. In fact, we could have pulled a 3 out of this right here. So here's what I'm going to do. I'm going to come up here. I'm going to take the 3 out front. I've got an x minus 1/3, an x plus 2, and what's left is x squared plus 9. Almost done. Now my depressed polynomial is a quadratic, and we've got lots of tools for solving quadratics. What's the answer that comes from here? When does that equal 0? Plus or minus 3i. So I'm going to write down the factors. 3, x minus 1/3, x plus 2, x minus 3i, and x plus 3i. Here are all the factors. And then let's write down the zeros. 1/3, minus 2, 3i, and negative 3i. There are all 4 of the zeros and all 4 of the factors. Any questions? Okay. And are these on the list? Okay. Watch carefully. Think for a second. Put the pieces together. Sven suggested we use 1/3. Now, I suspect Sven was back there going through and checking problems. We tried -1 and it didn't work. What would the next logical one most of us would have tried? -2. And would -2 have worked? Yes, we would have ended up with a different depressed polynomial, okay? But it still would have been something that we could either, listen carefully, do the P and Q stuff on again, or try and factor. Always take out the greatest common factor. Out of here, it would have been a really good idea to pull out the 3 to start with, out of all of them. That would work well. Okay, any questions? Okay, let's take a look at the next one. The instructions here are a little bit different, but they are really good because they help us out a lot. This is degree 3. How many complex zeros are we finding? 3. How many did they give us? Well, they really gave us 2, didn't they? They really gave us 2i and negative 2i. So if they gave us those 2 zeros, they really gave us 2 factors, one factor of x minus 2i and one factor of x plus 2i. Okay, listen carefully. If these 2 are factors of this polynomial right here, if I multiply these together, I'd get x squared plus 4. If these 2 are factors of this original polynomial, shouldn't this be a factor of that original polynomial? So can anybody think of how I'd get the depressed polynomial? What is it? Division. Can I do synthetic division with this? Not synthetic division with this, because it's got to start off with a plain old x, plus or minus a number. If it's x squared, we've got to do long division, but that's actually not too bad here. Plus, it's good practice for the test. And we know that it's going to go in evenly. We know that the remainder is going to be 0. So let's take a good look here. Again, when you're doing long division, you're looking at this one, and you're thinking, what do I multiply x squared by to make it an x cubed? What do I multiply x squared by to make it an x cubed? Just an x. Once I put a number up here or an expression up here, I multiply, I distribute through, so that's going to be x cubed, and that's going to be 4x. I don't put it in this column, I put it in this column right here, and then I go through and I subtract. I change the signs. No x cubes, I've got a minus 4x squared. No x's, and I've got a minus 16. And again, I'm just looking at the x squared. What do I multiply x squared by to make it a minus 4x squared? Negative 4. Distribute through. Negative 4x squared minus 16. Go through and change the signs. What do I get? 0. Here's the depressed polynomial. Here's the last one. So if that's a factor, what's the 0 that comes from that? 4. So 1, 2, 3 zeros. Got them all. It's degree 3. It's going to have 3 zeros. We found them all. They gave us one imaginary one. That means they really gave us 2. All we had to do was find the factor that would correspond to those 2, do the long division, and out drops the other answer. Any questions? Lots of pieces to put together here. Let's take a look at this one right here. The instructions say find the complex zeros. So that means find all of them, including i's. And then write it in factored form. Okay, this is a degree 4 polynomial. We're missing a whole bunch of terms. We're missing an x cubed, an x squared, and an x term. Okay, but if we're going to find any answers, which ones do we try and find first? The nice ones, the rational ones, which means we use P and Q. What are P and Q here? Both 1. So our list of possible rational zeros are plus and minus 1. Now take a good look at that. Do they work? Does 1 work? If you plug in a 1, you get 1 to the 4th. That's 1 minus 1 is 0. So 1's going to work. What about negative 1? Negative 1 to the 4th is 1. Minus 1 is 0. So they're both going to work. So here's how you do this problem. Okay, this is going to be fairly lengthy, but we're going to get it pretty easily. Put a 1 in the box, and then I need to write this down for synthetic division. So that's going to be a 1, a 0, a 0, a 0, and a 1. 4th power, 3rd power, 2nd power, 1st power, and there's the constant on the end. That needs to be negative. Any questions? Bring down, multiply, add, multiply, add, multiply, add, multiply. Just like we expect. Here's the depressed polynomial. Now, if you wanted to, please don't write this down, but if you wanted to, you could write down x cubed plus x squared plus x plus 1. And then you could do the p and q stuff again on this. But what are p and q on this one also? They're both 1. Okay? And we already know that -1 works. So just like you did in I think it was section 2.3, let's put -1 in the box. Don't start over with the original one. Let's continue dividing out of the depressed polynomial. So we're going to do 1, 1, 1, and 1. And is this going to work? Absolutely this is going to work, because that's going to be a -1. That's a 0. That's going to be a -1. Whoops, that's going to be a 0. Take that back. That's going to be a 0. That's a 1. And this is going to be a -1. There's our 0. So I know that the two of these are zeros. And this right here, what is this? It's got a name, and you should know what polynomial it is. It's the depressed polynomial, right? If I took out an x out of x to the 4th, this is x cubed. What's this start off as? X squared. So this is x squared, no x's, and plus a 1. So I've got a factor of x minus 1 from this one right here. I've got a factor of x plus 1 from this one right here. And then I've got this extra x squared plus 1. Haven't we done several of these? What are the answers that come from here? Help me out here. It's Thursday, for crying out loud. It's not Monday morning. What are the two answers? Plus or minus I, right? So this would break down a little further. I'd have x minus 1, x plus 1, x minus I, and x plus I. There are the factors. And then let's write down the zeros. Here are the zeros. 1, -1, I, and -I. Whoops, make that look like a -I. Any questions? Okay, let's take a look at the very last one. On the test, I'm not going to let you use a graphing calculator because you have to graph some polynomials, and really these would be a little bit too easy if you had a graphing calculator, and let me show you why. Does this one look like fun? Holy cow, what's P? 52, Q, 3. Okay, now let's see, 52, 1 and 52, 2 and 26. Does 3 go in there? I think 3 does go in there. Does it? No? Okay, you can tell because you can add the two of those together, you get 7. 7 isn't divisible by 3. Okay, but let's see. So 3 doesn't go in there. 4? 4 does go in there. 4 goes in there 13 times. 5 doesn't. 6 doesn't. You can keep checking. Those are the factors. And then 1 and 3. So if I listed the possibilities, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 13, plus or minus 26, plus or minus 52, and then each one of those over 3. So plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, plus or minus 13/3. This is starting to hurt, isn't it? Plus or minus 26/3. And then 52, if you divide 52 by 3, you end up with, oh, no, yeah. So, yeah, we do have that, 52/3. Plus or minus 52/3. That's one ugly mess, isn't it? Any mistakes here? Okay, so here's the good news. I won't put one this difficult on the test. If you had one this difficult, what we do is we kind of blend a little bit of technology and we blend a little bit of the math that we know. How many zeros are we looking for? We're looking for 4. Grab your calculator, and here's what we do. Okay, remember on that other problem where they showed you a picture and they said just confirm that the zeros that are in your list of possibilities are actual the zeros there? So we're going to take the calculator and we're going to have it do some heavy lifting for us. So I'm going to clear this off and we're going to type in 3x to the 4th minus x to the 3rd minus 9x squared plus 159x and then minus 52. And then I'm going to hit zoom 6, just the standard window. And we're going to wait for it to graph. Okay, now, some of the possibilities were outside this window. Okay, but isn't that a point where it crosses right here? Okay, and I could hit trace. That looks like 1, 2, 3. That looks like -4. So I'm going to type in -4. Does -4 work? It does. So let's go through here and let's do synthetic division with a -4, and let's hope that the depressed polynomial is a lot easier to work with. So we're going to write down a 3, a -1, a -9, a 159, and a -52. And we know that we're going to end up with a 0. If we don't end up with a 0, then we've done something wrong. So we've got a 3, -12, -13. That's going to be plus 52. That's going to be, let's see, 43. If I multiply here, this is going to be -172. So this is going to be a -13. And multiply here, I end up with a 52. So I end up with 0. With me there? Okay. So that's a 0. Okay, let's come back here. Again, let's use the technology to make the work a little bit easier. Rather than worrying about every one of these, do I have another place where it crosses right here? I do. So let's do this. Let's hit zoom 4. That'll make it a little bit smaller. If this is 0 and this is 1, what does that look like? What does it look like? About a half. Or is a half on our list? A half isn't on our list. So what is it? It's got to be 1/3. So I'm going to hit trace and I'm going to hit 1 divided by 3. So I put it in there exactly. Exactly 1/3 and hit enter. It ends up being a 0. So does 1/3 work? Yes, it does. And that's a lot easier than working with this ugly depressed polynomial. So let's do 1/3 in the box, 3, -13, 43, and -13. And let's see what we get here. We better end up with a 0. So this is a 3. 1/3 times 3, 1. And look how nicely this works out. Every one of these is going to be multiples of 3. So that's going to be a -4. So that's going to be a 39. That's 13, and that's a 0. So this is also a 0. Now take a good look at this. I've got x plus 4 as a factor from this one. I've got x minus 1/3 as a factor from this one. And then I've got 3x squared minus 12x plus 39. If I'm going to finish this off, what should I do first? Take out a 3. So I'm going to pull the 3 out front. And then this is x squared, 4x, plus 13. That's right. Does that factor? Nope, but how do you finish? Quadratic formula. Okay, and I'll leave that for you to finish. Okay, 2.4 ought to be up here. Overnight, you want to work on 2.5. I'll take questions on 2.5 in the review. Make sure you pull up the review on the website, get that written down or print it so that you can be working on that tomorrow and over the weekend. Test is on Monday. Have a great day.